Unit 1.2, Lesson 2, Atomic Number and Atomic Mass. The periodic table contains valuable information about atomic structure. Each successive element contains atoms with one more proton than the previous element. The atomic number of an element is the number of protons in an atom of that element. In neutral atoms, the number of electrons is equal to the number of protons. The number of protons plus the number of neutrons in an atom provides the approximate mass of a single atom. The decimal number on the periodic table represents the average atomic mass of an element's atoms. As a result of this lesson, you'll be able to distinguish between atomic number, mass of an atom, and average atomic mass. You'll be able to describe the structure of an atom and draw a simple atomic model of an atom. And you'll be able to extract information from the periodic table related to atomic structure and atomic mass. The atomic number of an element is the same as the number of protons in the nucleus of an atom of that element. In a neutral atom, the number of protons is the same as the number of electrons. This is why a neutral atom has no net charge. In the periodic table, the elements are arranged in order by atomic number, which is equal to the number of protons in that nucleus. Each successive element has one more proton than the element before it. It is the number of protons that makes atoms of one element different from atoms of another element. Likewise, assuming the atoms are neutral, each successive element has one more electron than the element before it. The atomic number does not tell you how many neutrons an atom of an element has. However, for smaller atoms, the number of protons is close to the number of neutrons. Protons and neutrons account for most of the mass of an atom. A proton and a neutron each have a mass of 1 AMU, or atomic mass unit. By comparison, the mass of an electron is 0.0005 AMU, or about 1/2000th the mass of a proton or neutron. Therefore, the mass of an atom in atomic mass units is approximately equal to the sum of the number of protons and neutrons, because the mass of the electrons is so small. You can estimate the number of neutrons in an atom by subtracting the number of protons from the average atomic mass of the element, rounded up to the nearest whole number. For example, neon has atomic number 10 and an average atomic mass of 20.1797 AMU, which means we can expect a typical neon atom to have a mass of 20 AMU. The atomic number indicates 10 protons in the nucleus, each with a mass of 1, giving a total mass of 10. So there must be 10 more neutrons to account for the remaining mass. The atomic mass of an atom, determined by summing the number of protons and neutrons, is not identical to the average atomic mass of the element given in the periodic table. This difference will be discussed further in future lessons. If you change the number of protons in an atom, you also change the elemental identity of that atom. For example, if you could somehow add a proton to the nucleus of a carbon atom so that it went from 6 protons to 7 protons, you would no longer have a carbon atom, but a nitrogen atom. Thus, if you know the number of protons in an atom, you can also figure out its identity. Wrapping up this lesson, how are the atoms of one element different from those of another element? Each element in the periodic table has one more proton than the element preceding it. The atomic number of an element is the same as the number of protons in the nucleus of each of its atoms. In a neutral atom, the number of electrons is equal to the number of protons. And finally, the mass of a proton is 1 atomic mass unit, 1 AMU. The mass of a neutron is also 1 AMU. The mass of an electron is so small it is considered negligible, which means that we can ignore it. So the mass of an atom in atomic mass units is simply the sum of the number of protons and the number of neutrons.